Let's take a moment to consider the following quadratic equation. Clearly a quadratic, the coefficient of x squared is 1, the constant term is -5, there is no coefficient of x, but that's fine because b is allowed to be 0. So, I want to solve this equation. Let's try to think about some ways we could go about doing this. Well, if we go back to what we've studied in the section on radicals, I happen to know that this equation is the same as this. And remember, we had a rule that x squared was equal to 5 if x is plus or minus root 5. Because we said x squared is equal to a implies that x equals plus or minus root a. Well, we're actually done with this equation because, hey, that happens to be your answer. We already know that x is either plus root 5 or minus root 5. If you don't like to write it this way, you could write x equals square root of 5 or x equals negative square root of 5. That's what that plus or minus symbol means. It's just a short way of writing both in one step. There's two solutions here when you see this symbol. It's not just one number that just happens to be two numbers at the same time. I don't think, hopefully, any of you were thinking that. So, this or this. However, let's say you weren't thinking in that direction and you wanted to sort of factor this. Well, this is a difference of squares. Because there is a number where the square of that number gives me 5. What is that number? Well, that number is square root of 5. And we had a formula for difference of squares that tells us that x squared minus a squared is x minus a, x plus a. Or x plus a, x minus a, however you want to do it. A times b is b times a in this course, so that's fine. And now we can use the fact that a product is 0 when one of the two pieces is 0. So either this is 0, or this is 0. So we get this, or this, which was the same solution that we got right up here. Okay, so what did we do? Well, we did the same problem in two different ways. One using a rule that we developed before in the section on radicals. One using a difference of squares. Even though this doesn't look like a square right off the bat, it is the square of a number, so we can use that rule. We can use that formula for a difference of squares. And you'll notice that if we have x squared minus a constant is equal to 0, this was really, this was short, right? We jumped, boom, boom, much shorter than some of the problems that we've looked at so far. So this is good. I sort of like it when I have a square minus a constant equals 0 when there's no coefficient of x. Let's look at one more example. Okay, let's look at this. X minus 2 squared minus 3 equals 0. So I could multiply this all out to get this into the form ax squared plus bx plus c equals 0. That's perfectly doable. As a matter of fact, if I wanted to prove to you that this is a quadratic equation, which means it can be written in the form ax squared plus bx plus c for a non-zero, then what I could do is I could multiply this out. X squared, what am I going to get? I'm going to get minus 2x twice, minus 4x plus 4 minus 3 equals 0. So this clearly is a quadratic equation. A would be 1, B would be -4, C would be 1, the A is non-zero, all is good. But I'm suggesting that we don't do this. We try to get by the way that we got by just a moment before, where we were trying to solve x minus 2, or when we were trying to solve x squared minus a constant equals 0. Here we're trying to solve x minus 2 squared minus a constant equals 0. And I know from my rule that this means that x minus 2 must be equal to plus or minus the square root of 3. How do I know this? Well, I know that if, let's say, y squared is equal to a, then y is equal to plus or minus root a. So just allowing my y here to be x minus 2, I get that x minus 2 is equal to plus or minus root 3. So, what can I do? I can add 2 to both sides, and I'm done. I don't have to do any factoring. I don't have to do anything much at all. If I have something squared equals a constant, the problem's pretty much over. Very short amount of work needs to be done in order to solve it. Okay, so I like this. I like equations where I have something squared is equal to a constant. Is there a way to write something in this form? Because if I had given you this x squared minus 4x plus 1 equals 0, you might not see right away that this is the same as this. So how can we get from here to here? Let's talk about that next.